Hello students, welcome to ASN Chemistry. Today class we are going to learn CBSE previous year's numericals from Electrochemistry chapter. I will cover all the models from the chapter, so please watch complete video. Definitely you will get benefit. Look at this. I will cover E naught cell, delta G naught, equilibrium constant, E cell or EMF of cell, oxidizing power, reducing power. Next, conductivity, resistivity, molar conductivity, degree of dissociation, dissociation constant, how to find out limiting molar conductivity of strong electrolyte, weak electrolyte. Next, problems on Faraday first law and second law. First question, CBSE 2020. Here one cell reaction is given. Standard reduction potentials of zinc and copper also given. We have to find out E naught cell and delta G naught. See, first, how to find out E naught cell? E naught cell formula, E naught cathode minus E naught anode. E naught cathode minus E naught anode. Now we have a question how to find out which is cathode, which is anode, because here zinc is given, copper is given, right? So remember, the electrode where reduction takes place, that one you can take as a cathode. The electrode where oxidation takes place, there, that one you can take as a anode. Got it, right? So in this reaction, if you observe here, copper plus 2 oxidation state, here element 0. Oxidation number decreases, that one you can take as a reduction, right? And next, here Zn count into Zn2 plus, here oxidation number 0, here oxidation number plus 2, increase in oxidation number is called as oxidation. Okay, so which one cathode we have to take? Copper, right? So that's why E naught Cu2 plus 2 Cu minus E naught Zn2 plus 2 Zn we have to take. Got it, right? So now, what is the copper value given in the question? 0.34, zinc value minus 0.76. So let us write plus 0.34 minus 0.076. Minus into minus plus, right? So if we add both, we will get 1.1 volt. Okay, next, second one, delta G naught we have to find out. What is the delta G naught formula? See here, second one, delta G naught equal to minus NF E naught cell. Very simple formula, minus NF E naught cell. Okay, so now what is N? Here N is nothing but number of electrons involved in the redox reaction. Here zinc losing 2 electrons converted into Zn2 plus, and Cu2 plus gaining those 2 electrons only converted into Cu. So here how many electrons are involved? 2 electrons, right? So that's why minus 2 into F for Faraday. Faraday value 96,500 coulomb per mole, charge of 1 mole of electrons, into what is the E naught cell just before we find out, right? 1.1 volt. Equal to, if you multiply all these three, we will get minus 212 300. Here coulomb into volt, nothing but joule per mole, right? Let us count into kilojoules also, minus 212.3. see here, 212.3 kilojoule per mole. Got it, right? Next question, CBSE 2022-2020-2015. Here one cell reaction is given and standard reaction potential of nickel and silver are given. We have to find out E naught cell, delta G naught, maximum work and log Kc. K indicates equilibrium constant. First E naught cell formula, E naught cathode minus E naught anode. Right. So here Ag plus converted into Ag, undergo reduction, you can take as a cathode. Ni converted into Ni2 plus, undergo oxidation, you can take as a anode. Now what is the silver reduction potential is given? 0.80 minus, and what about nickel value? Minus 0.25, right? So here minus into minus plus, If you add both, we will get 1.05 volts. Delta G naught equal to minus NF E naught cell. Minus NF E naught cell. Here what is N? You can observe here. Ni converted into Ni2 plus, losing 2 electrons. Or Ag plus converted into Ag. Here 2 moles are involved, so 2 electrons. So how many electrons are involved? 2 electrons are involved. So 2 into Faraday value 96,500 coulomb per mole. And E naught value, just before we find out, 1.05 volts. Okay now, and if you multiply these two, we will get answer minus 202,650 joule per mole. Okay now, we can convert it into kilojoules. How do you convert it into kilojoules? Minus 202.65 kilojoule per mole. Got it. Next one, maximum work. Maximum work is nothing but minus delta G naught. So this value is there, right? You can multiply with minus, minus into minus, plus you will get. So answer is 202.65 kilojoule per mole. Got it. Next we have to find out log Kc. This is the formula, E naught cell equal to 0.059 by n log Kc. We want log Kc, right? So log Kc is equal to, right, this part you can send left hand side. So we will get E naught cell into n divided by 0.059. Okay, now what is the E naught cell? We find out already. Its value 1.05 volts. Okay now, and next into n value 2 divided by 0.059. If you multiply and divide, you will get log Kc value. Log Kc value approximately 35.60. Okay, sometimes they will ask Kc value. That time how to do? Look at this. If you want Kc, then Kc equal to, if log goes to right hand side, it converted into anti-log. Anti-log. And what is the value? 35.6. 35.6 you can write as a 0.6 plus 35 plus 35. Anti-log 35. Anti-log 35 nothing but 10 to the power of 35. Right. And 0.6 they will only give in the question. Don't worry, they will give in the question. So anti-log 0.6, its value is 3.98. Got it? Next question, CBSE 2019. Here cell representation is given. Standard reduction potential of nickel and aluminum also given. We have to find out E naught cell and EMF of cell. Okay. And this is cell representation. First I will convert this cell representation into cell reaction. Here in this place, Al to Al3 plus, this is anode reaction. Ni2 plus to Ni, this is cathode reaction. Okay, left side anode, right side cathode. And this double vertical line indicates salt bridge. Okay, now, so first I will write cell reaction. First you can observe here, aluminum solid, right. Next, second part, Ni2 plus concentration 0.1 molar converted into, here Al converted into Al3 plus, right. So you can write Al3 plus in bracket concentration 0.001 molar plus, here Ni2 plus converted into Ni, that's why Ni solid. Okay now, and one more important thing is here Al converted into Al3 plus, it is losing how many electrons? 3 electrons. Here Ni2 plus converted into Ni, it is gaining how many electrons? 2. Remember, always losing of electrons should be equal to gaining of electrons. That's why into 3 and into 2 you do. Now both become 6, right? So 6 electrons are involved in the reaction. Since you multiplied with into 2, you write 2 multiplied with 3, right? That's why 3 you can write. Okay. First, E naught cell equal to E naught cathode minus E naught anode. And here Ni undergo reduction. You can observe Ni2 plus to Ni taken as a cathode, Al converted into Al3 plus undergo oxidation taken as a anode. And what is the nickel standard reduction potential value? Minus 0.25 minus. What about aluminium? Minus 1.66 volts. Minus into minus plus, right? If we add both, we will get 1.41 volts. Next, let us find out EMF of cell. EMF of cell, right? E cell equal to, what is the formula? We have to write Nernst equation. E naught cell minus 0.059 by N log product concentration divided by reactant concentration, right? If stoichiometric coefficient is there, you have to write as a power, right? Now equal to, so here let us write once again, E naught cell minus 0.059 divided by, what is the N value here? N, 6 electrons are involved, right? 6 electrons, so 6 log product concentration. Product, what is the product? Al3 plus how many times? 2 times, right? So that's why Al3 plus whole square divided by reactant Ni2 plus, right? How many moles? 3 moles, right? So that's why Ni2 plus power 3 you write, okay? Don't forget, you should write these powers, okay? In general, students, they do mistake here only. You have to write powers, okay now. And next, let us substitute all the values. And E naught value, just before we did, right? What is the value? 1.41 minus 0.059 by 6, okay? Log, what is the Al3 plus concentration? 0.001, nothing but what? 10 to the power of minus 3, okay? Whole square divided by Ni2 plus concentration 0.1, right? So that's why 10 to the power of minus 1 whole cube, okay? Next step, equal to 1.41 0.059 divided by 6 log 10 power minus 3, this is 3 into 2, 10 power minus 6. Okay, 10 power minus 3 if goes to here plus 3, right? So minus 6 plus 3, what will you get? Log 10 power minus 3. Log 10 power minus 3. Okay, and next 1.41 minus 0.059 by 6. Log 10 power 3 and nothing but minus 3 log 10. Minus 3 log 10. Log 10 value 1. That's why what will you get? Minus 3. Here minus into minus will become plus, and we can cancel this part, right? How many times? 2 times. And 0.059 by 2, right, equal to here 0.0295. If we add both, we will get 1.439. This is Nernst equation problem, very very important. Next question, CBSE 2021 sample question paper. Here standard reduction potentials of chlorine, dichromate, permanganate are given. We have to find out strongest oxidizing agent. Very simple question. Look at this. Oxidizing power directly proportional to standard reduction potential. So in these three, which has high value? You can observe 1.36, 1.33, 1.51. Which is the high value? This one, right? So answer is right, potassium permanganate or MnO4 minus. Next question. NEET 2019 I have given here. Standard reduction potential of aluminium, potassium, silver and chromium are given. Finding reducing power. So how do you find out? So reducing power inversely proportional to SRP. Inversely proportional, right? It means what? Lesser the value, more is the reducing power. Here I given answer. Potassium has the least value, minus 2.93. So, and silver has the highest value, 0.8. So this is the reducing power decreasing order. Next question, CBSE 2022. Limiting molar conductivity of Mg2 plus and Cl minus are given. We have to find out limiting molar conductivity of MgCl2. Okay, so here limiting molar conductivity of MgCl2 is equal to, which contains which ions? One Mg2 plus ion and two Cl minus ions, right? So which is equal to limiting molar conductivity of Mg2 plus ion plus 2 into, because 2 chloride ions are there, 2 into limiting molar conductivity of Cl minus ion. Okay, and here Mg2 plus, what is the value? 106 plus 2 into Cl minus is 76.3. So 106 plus 2 into 73.6 is 152.6, which is equal to, if we add both, we will get 258.6 Simon units, centimeter square mole inverse. Next question, CBSE 2022-2016. In this question, conductivity of 0.001 molar acetic acid solution is given, and limiting molar conductivities of H plus and acetate ions also given. We have to find out molar conductivity and degree of dissociation. Okay, first let us find out first limiting molar conductivity of acetic acid, also called as ethanoic acid, CH3COOH, which is equal to limiting molar conductivity of acetate ion, CH3COO minus, plus limiting molar conductivity of H plus ion. Okay, so in this case, because this is nothing but what, CH3COO minus and H plus, right? That's why we written like this. And next, here acetate ion value 40.9 plus H plus ion value 349.6. Okay, now if we add both, we will get 390.5 units Simon centimeter square mole inverse. Okay, now so this is the first step. And next, in second step, let us find out molar conductivity. What is the molar conductivity formula? Molar conductivity equal to kappa into 1000 divided by molarity. Here what is the conductivity given in the question? Look at this. Conductivity is given 3.9 into 10 power minus 5, and this is the concentration. Okay, so let us write here 3.905 into 10 to the power of minus 5 into 1000 divided by molarity 0.001, nothing but 10 power minus 3. Okay, simple calculation only. If you do this calculation part, we will get answer 39.05 Simon centimeter square mole inverse. Got it, right? And next one, third one, let us find out degree of dissociation. Degree of dissociation alpha equal to molar conductivity divided by limiting molar conductivity. What is the molar conductivity? You can observe here 39.05. Limiting molar conductivity, you can observe here, we find out limiting molar conductivity, right? 390.5. Right, if you do the calculation, simple calculation only, we will get 0.1. Okay, sometimes in questions they are asking, right, dissociation constant also, acid dissociation constant, right? So here acid dissociation constant Ka equal to formula C alpha square divided by 1 minus alpha. What is the concentration? Look at this, here already we written concentration, right? 10 power minus 3, right, into what is the alpha? Alpha is 0.1, nothing but 10 power minus 1 whole square, and 1 minus 0.1, right? If you multiply this, you will get 10 to the power of 5 divided by 0.9 here, and if you do the calculation part, we will get 1.11 into 10 to the power of minus 5 units mole per liter. Understood? Next question, CBSE 2020. Here a resistance is given. Next, length and area of cross section of column also given, and concentration is given. We have to find out conductivity, resistivity and molar conductivity. Okay, first of all, here what is the resistance given? Resistance R equal to, right, 5 into 10 power 3. 5 into 10 power 3 ohm. Okay, and next, what is the length? 50 centimeters. Length equal to 50 centimeters. And what is area of cross section? 0.625. Area of cross section 0.625 centimeter square. And what is the concentration given? Molarity. Molarity 0.05 molar. Okay, now first let us find out conductivity. Conductivity formula. Conductivity kappa equal to G into G star. G into G star. Okay now. And next here G is nothing but 1 by resistance. Conductance equal to 1 by resistance into cell constant equal to length divided by area of cross section of column. Right. Now 1 by R. What is the resistance given in the question? 5 into 10 power 3. 5 into 10 power 3 into L 50 centimeters and area of cross section 0.625. Okay, now if you do this calculation part, we will get answer 0.016 Simon centimeter inverse. Okay, so this is for conductivity. Okay, next what we have to find out? We have to find out next resistivity. Resistivity rho equal to 1 by kappa, 1 by conductivity. So 1 divided by 0.016. Okay, so this one shall I write like this? So 0.016 nothing but, right, 16 into 10 power minus 3. So if 10 power minus 3 goes here, it becomes 1000, right? So that's why 1000 divided by 16, which is equal to, we will get, if you do the calculation part, so 62.5, right, units ohm centimeter. Next what we have to find out? So this is second formula. Okay, next we have to find out molar conductivity, right? So molar conductivity lambda m equal to kappa into 1000 divided by molarity. Okay, so here conductivity we find out already, right, 0.016. so we can write like this, right, 16 into 10 power minus 3. 1000 we can write as a 10 power 3 divided by molarity how much? 0.05. so nothing but 5 into 10 power minus 2. Right, in this case 10 power minus 3, 10 power plus 3 cancel, and if you do this further calculation part, right, we will get answer 320. What are the units? Simon centimeter square mole inverse. Got it? Next question, CBSE 2014. Here two kind of concentrations given, 0.1 molar and 0.2 molar. Okay, so first let us write the data here. 0.1 molar concentration, other one is what? 0.02 molar concentration. Right, for 0.1 molar concentration, what is the resistance given? 100 ohm. So resistance equal to 100 ohm. In case of 0.02, how much given? 520 they given. So resistance for this 520 ohm. Okay, next conductivity of for 0.1 molar KCl solution, how much? Conductivity kappa K equal to 1.29 into 10 power minus 2, right, ohm inverse centimeter inverse or Siemens centimeter inverse. Okay, next here what we have to find out, observe here, conductivity and molar conductivity of 0.02 we have to find out, 0.02. So in this question, if you observe carefully here, cell is same. So this is most important, same conductivity cell. When conductivity cell is same, cell constant also same, right? So here in first step we find out cell constant, and in second step we substitute here. So first let us find out cell constant. Cell constant, right? First conductivity kappa equal to, what is the formula? G into G star. G into G star. Then kappa equal to G star divided by G, nothing but 1 by R, right? So divided by R. We want G star, right? So that's why finally G star equal to kappa into R equal to. Now you can substitute values. What is the conductivity K? 1.29 into 10 power minus 2 into, what is the resistance? 100, right? So 100 nothing but 10 power 2. 10 power minus 2, 10 power plus 2 cancel. We will get 1.29 units, right? Here centimeter inverse we got. So this is the first formula. Okay, and next here we have to find out conductivity and molar conductivity of 0.02 molar, right? So first conductivity K equal to G into G star. So nothing but G star divided by resistance. Okay, now so G star we find out just before, right? How much? 1.29, right? So you can write here 1.29 centimeter inverse divided by, what is the resistance for this? 520 ohm, right? So if you do this calculation part, we will get answer 2.48 into 10 power minus 3 Siemens centimeter inverse will get. Next we have to find out lambda m, molar conductivity equal to kappa into 1000 divided by molarity. Just before we find out conductivity, right? So 2.48 into 10 power minus 3, 1000 we can write as a 10 power 3 divided by, what is the molarity? 0.02, nothing but 2 into 10 power minus 2, right? In this case these two will be cancelled. If 10 power minus 2 goes here, convert into 10 power plus 2, nothing but 248. 248 by 2, how much? 248 by 2, nothing but 124 Siemens centimeter square mole inverse. Understood? CBSE 2019. Here zinc rod is placed in 0.01 molar zinc sulfate solution. Standard electrode potential is given. We have to find out electrode potential of zinc. Okay, first let us write cell reaction for this. Zn2 plus, what is the concentration given in the question? 0.01 molar. 0.01 molar. Okay, gain 2 electrons converted into zinc solid. Okay, now so write Nernst equation for this. Electrode potential of zinc or reduction potential of zinc is equal to E naught Zn2 plus 2 zinc minus 0.059 by n log, right? Here zinc solid, so no need to write. So 1 divided by Zn2 plus concentration. Pure solids we no need to mention. Okay, now and let us write values here. So what is the standard electrode potential of zinc given in the question? Minus 0.76 minus 0.76 minus 0.059 by how many electrons are involved? 2 electrons, right? That's why 2 log 1 divided by Zn2 plus concentration. How much? 0.01, nothing but 10 power minus 2. Here log 1 by 10 power minus 2. So this is denominator. If you change into numerator, how do you write? Log 10 power plus 2. Okay, now and log 10 power 2, nothing but what? 2 log 10. 2 log 10. We know that log 10 value 1. Log 10 value 1 and 2 cancel. then what will you get? Minus 0.76 minus 0.059. If you add both minus values, we will get minus 0.819 volts. Got it right? Next, CBSE 2022. On left side anode, right side cathode. Here double vertical line indicates salt bridge. At anode, oxidation takes place, Fe converted into Fe2 plus. At cathode, reduction takes place, H plus converted into H2. Okay, in this question, E0 cell is given. We have to find out EMF of this cell. Okay. First, let us write cell reaction for this. Here, Fe converted into Fe2 plus. So, Fe solid converted into Fe2 plus aqueous. Its concentration 0.001 molar. Okay, next here H plus converted into H2. H plus, right, concentration 0.01 molar, right, converted into H2 gas 1 bar pressure. Okay, next here remember one thing, here 2 hydrogens are there, so you write 2 here. So here iron losing 2 electrons converted into Fe2 plus and 2 H plus ions gaining those 2 electrons converted into Fe. So N value 2 here. So let us write Nernst equation for this. E cell equal to E0 cell minus 0.059 by N log product concentration divided by reactant concentration. What is the product concentration? Fe2 plus divided by, here anyway H2 gas 1 bar pressure, right? So no need to mention, divided by H plus concentration. Here very important, the stoichiometric coefficient you should write as a power. Okay, many students forget this. Okay, you should write as a power. And next step, here what is the E0 cell given in the question? 0.44. So 0.44 minus 0.059 by, what is the N value? Fe converted into Fe2 plus. Okay, 2 electrons are involved here. Next, Fe2 plus concentration 0.001, nothing but 10 power minus 3 divided by H plus concentration 0.01, nothing but 10 power minus 2. So don't forget square is there. And remember one more thing, for hydrogen standard electrode potential or standard action potential is 0. Okay, next step. Here denominator 10 power minus 2 whole square, nothing but 10 power minus 4. If 10 power minus 4 goes here, 10 power plus 4. So plus 4 minus 3 log 10 power 1. Got it right? So we know that log 10 value 1. So remaining 0.059 by 2, nothing but 0.0295. Okay, if you do this calculation part, we will get answer 0.4105 volts. CBSE 2014. How much charge in terms of Faraday is required for reduction of 1 mole of Cu2 plus to Cu? So in this Cu2 plus gain 2 electrons converted into Cu. Okay, so here for 1 mole of Cu2 plus, conversion of 1 mole of Cu2 plus to 1 mole of Cu, we need how many moles of electrons? 2 moles of electrons. Okay, look at this. Charge of 1 mole of electrons, right? 1.60 into 10 to the power of minus 19. This is charge of single electron. And 1 mole 6.022 into 10 power 23. If you multiply these two, we will get approximately 96,500 coulombs. It is taken as a Faraday. Okay, 1 Faraday equal to 96,500 coulombs. Remember, 1 Faraday equal to 96,500 coulombs. So in this reaction, here 2 moles of electrons. 2 moles of electrons are nothing but how many Faradays? 2 Faradays. How many Faradays? 2 Faradays. Right. So if they ask charge, anyway they have asked Faraday, so answer 2 Faraday. Sometimes they ask charge in coulombs. That time what we have to do? 2 into 96,500 coulombs. Right. If you multiply, we will get 193,000 coulombs. CBSE 2020, how much charge in terms of Faraday is required for reduction of 1 mole of MnO4 minus to Mn2 plus? So here MnO4 minus, it is called as permanganate, converted into Mn2 plus, Mn2 plus, right? So what is the charge of Mn2 plus here? Charge is plus 2. What about here in this manganese? Here I will tell you how to calculate. First you can take manganese, so we don't know, unknown, so X, 4 oxygens, each oxygen minus 2, equal to what is the charge on the compound? Minus 1. So this minus 1. Then X equal to what will you get? X equal to plus 7. Okay, so what is the charge? Plus 7. So here plus 7 converted into plus 2. Plus 7 converted into plus 2. So it is gaining how many electrons? It's gaining 5 electrons. Right, and they're asking for 1 mole. For 1 mole you need how many moles of electrons? So you need 5 moles of electrons. So nothing but 5 Faraday. If they ask in terms of coulombs, 5 into 96,500 coulombs we have to do. Right, if you multiply, we will get 4,82,500 coulombs. Understood? CBSE 2020, how many coulombs are required for oxidation of 1 mole of H2O to O2? Right, so let us write H2O here. H2O, right, here H2O is converted into O2. Here how many oxygens are there? 1 oxygen, right? That's why you can write half O2. Right, we know that for any element oxidation number equal to 0. Here oxygen element oxidation number is 0. And what about this oxygen? Look at this. So here I will tell you how to find out. 2 hydrogens are there. That's why 2 into each hydrogen plus 1. Plus oxygen unknown. So X equal to, is there any charge here? No, right? Neutral. That's why 0. X equal to minus 2. So what is the oxidation number? Minus 2. So here minus 2 converted into 0. So it is losing then how many electrons? 2 electrons. So for 1 mole of conversion of H2O to of O2, we need 2 moles of electrons. 2 moles of electrons nothing but what? 2 Faraday. It is nothing but 2 into 96,500 coulombs, right? Which is equal to 1,93,000 coulombs. Got it? CBSE 2013, how much electricity in terms of Faradays is required to produce 20 grams of calcium from molten calcium chloride? First you can take calcium chloride, CaCl2. Okay, so CaCl2 split into Ca2 plus 2 moles of Cl minus. Okay, so here we have to focus on calcium, right? So you can take calcium Ca2 plus converted into Ca. It can gain how many electrons? Plus 2, right? So it gain 2 electrons. So this indicates formation of 1 mole of calcium, we need 2 moles of electrons. Okay, now what is the mass of 1 mole of electrons? Nothing but 40 grams. Charge of 2 moles of electrons nothing but 2 Faraday. Okay, here 40 grams of calcium, formation of 40 grams of calcium, we need 2 Faraday. How many Faraday? 2 Faraday. Then formation of 2 grams of calcium, we required how many? Half of that, right? 1 Faraday, or 96,500 coulombs. CBSE 2017, calculate mass of silver deposited at cathode when a current of 2 amperes was passed through silver nitrate solution for 15 minutes. Here molar mass of silver 108 gram per mole. Okay, first of all, AgNO3. Here AgNO3 you can split into AgNO3 split into Ag plus NO3 minus. Ag plus and NO3 minus. So we have to focus on Ag, right? So that's why Ag plus gain 1 electron converted into Ag. Okay, now we have to use formula, Faraday first law. So that is weight equal to Z into I into T. Z into I into T, and which is equal to Z equal to equivalent weight divided by 96,500. 96,500. Remaining is what? I into T. Okay now. And next, which is equal to here equivalent weight equal to atomic mass divided by charge. Right, what is the atomic mass of silver? 108. And what is the charge on Ag? Plus, right? So 108 divided by 1, again 108 only, right? Into I, 2 amperes. So 2 into, don't forget we should take time in terms of seconds. That's why 15 into 60 seconds divided by 96,500 coulombs. Right. So if you do this calculation part, we will get answer 2.014 grams of silver. CBSE 2014. Calculate mass of nickel deposited at cathode when a current of 5 amperes was passed through nickel nitrate solution for 20 minutes. Okay. First you can take nickel nitrate, split into Ni2 plus and 2 moles of NO3 minus. Okay, and here they are asking mass of nickel, that's why Ni2 plus converted into Ni by gaining 2 electrons. Okay, now double equal to EIT divided by 96,500. So here what is the equivalent weight? Nothing but atomic mass divided by charge. What is the atomic mass given in the question? 58.7 divided by, what is the charge on Ni2 plus? Plus 2, right? That's why divided by 2 into, what is the I value given in the question? 5 amperes. So 5. Next, time 20 minutes. So we should convert it into seconds, right? So 20 into 60 divided by 96,500. Okay, now so here if you do this calculation part, here 0 0 cancel, 0 0 cancel, remaining calculation if you do, we will get answer 1.825 grams. CBSE 2020. How many seconds does it require to reduce 3 moles of Fe3 plus 2 Fe2 plus ferric to ferrous with 2 amperes current? Okay, so here Fe3 plus converted to Fe2 plus by gaining how many electrons? 1 electron. But here asking for 3 moles, right? That's why you can take 3, 3, 3. So to conversion of 3 moles of Fe3 plus 2, 3 moles of Fe2 plus, we need 3 moles of electrons. 3 moles of electrons are nothing but 3 Faraday. Okay, so here formula Q equal to I into T. Q equal to I into T. What is Q? 3 Faraday. 3 Faraday nothing but 3 into 96,500 coulombs. What is the I given in the question? 2 amperes. So 2. And time we have to find out. So T. Then T equal to 3 into 96,500 divided by 2. If you do this multiplication and division, we will get this value. CBSE 2017. How many electrons flow through a metallic wire if a current of 0.5 amperes is passed for 2 hours? Okay, first of all let us find out quantity of electricity passed through the metallic wire. Q equal to I into T. Q equal to I into T. Remember this formula. I equal to, right, current 0.5 amperes, 0.5. T for time in seconds, so 2 hours given, so 2 into 60 into 60 converted into seconds. Okay, now so if you multiply 0.5 into 2, nothing but 1, 60 into 60, 3600 coulombs. Now number of electrons passed through the metallic wire. So how do you do? Total charge divided by charge of single electron, charge of 1 electron. Okay, now what is the total charge you find out in the question? Right, here 3600. Here we find out 3600. Charge of 1 electron. Remember 1.602 into 10 to the power of minus 19 coulomb. 1.602 into 10 to the power of minus 19 coulombs. Right. So if you do this calculation part, we will get 2.25 into 10 to the power of 22 electrons. CBSE 2020. If you observe this question, we feel it is so lengthy answer and tough, but very simple question. Solution is very simple. Just you can use this formula, W equal to EIT divided by 96,500. Okay. First let us read the question. When a current of 2 amperes was passed through two electrolytic cells A and B containing zinc sulfate and copper sulfate in series, 2 grams. First what? 2 grams of copper. 2 grams of copper were deposited at cathode. Right. So how long current will flow? In first step, what we have to find out? So look at this. Use this formula. Everything is given. First step, you have to find out time. Okay. Now, second step. What mass of zinc is deposited at cathode? Right. In second step also same formula, but this time you have to find out W. Okay. First, here 2 grams of copper was deposited at cathode, and time we have to find out. So first you can take copper sulfate. Okay. So CuSO4 split into Cu2 plus and SO4 2 minus, and this Cu2 plus gain 2 electrons converted to Cu at cathode. What is the formula? W equal to EIT divided by 96,500. First of all, what is W? See, first W, right? Weight given 2 grams and equivalent weight, atomic mass divided by charge. So 63.5 divided by charge plus 2. Okay. Now, and here current given 2 amperes current. We have to find out the time. Here mass 2 grams, 2 grams of copper divided by equivalent weight, right? So 63.5 divided by charge. What is the charge on copper? Plus 2, right? So divided by 2 into, right, here 2 amperes current is given. So 2 into time we have to find out divided by 96,500 coulombs. If you do this calculation part, we will get time. Time we will get 30-40 seconds. 30-40 seconds. Okay. Now, second step, what we have to find out? See, what mass of zinc was deposited at cathode. Okay. Now, so first zinc sulfate split into Zn2 plus and SO4 2 minus, and Zn2 plus gain 2 electrons converted to Zn at cathode. So what is the charge on zinc? Plus 2. So here equivalent weight. What is the atomic mass of zinc is given? 65. 65. And what is the charge? Plus 2, right? So divided by 2 into I. Anyway, we know that 2 amperes current. Time here we find out, right? Because both cells are in the same series. So same time, 30-40 divided by 96,500 coulombs. Then what will you get weight? If you do this calculation part, we will get answer 2.047 grams. I hope you like this video. Please subscribe our channel and share this video to your friends and classmates, so they will also can get benefit from this. Okay. Love you all. Bye bye.